Welcome back everyone to another video here on the Unknown Coder YouTube channel. Today we are taking a look at another LeetCode problem. This time around we are taking a look at valid mountain array. This one is a pretty interesting question, not necessarily difficult or hard or anything like that, but it's still pretty interesting. So this problem states that given an array of integers array, return true if and only if it's a mountain array. Now, what in the world is a mountain array? Well, they give us a few things to verify what a mountain array is. The first one is that the array.length has to be greater than 3. So if the length of the array is not greater than or equal to 3, then we automatically know that we can go ahead and return false. Then it gives us some pretty long and gross looking equations here. So this says there exists some I with 0 is less than I is less than array.length. So this just basically means that somewhere inside of our array called R, there's going to be an index such that array of 0 is less than array of 1, is less than array of I minus 1, is less than array of I. So basically this just means that there's a buildup to a peak on array I, and then there's going to be an array such that array I is greater than array I plus 1, all the way down to array of array length minus 1, meaning that we have a way back down. So we're looking for an array that has a peak index called I, and this is going to be the largest value. It needs to go up and it needs to go down. However, this has to be strictly increasing rather than just not strictly increasing. So if we take a look at the example images they have below, we can see that a valid mountain array starts out as 0, 2, 3, 4, 5. And in this case, the index I is equal to 5. So we hit the peak at index 5 and then it starts going down to 1, 0. So basically we go up, then we go back down. Something that is not a legal mountain array is if we go 0, 2, 3, 3. The reason why this is not valid is that even though we do have a peak at 5 right here, it levels off at 3, meaning that it doesn't strictly increase. Whenever we're doing this, it has to strictly, so basically whenever we're on our way up, the values always have to go up. Whenever we're on our way down, the values always have to go down. So let's go ahead and take a look at a couple more examples that they've given for us. For example, number 1, we have the array of R is equal to 2 and 1. Here, if we go ahead and take a look, this is only equal to 2. So that means that length is less than 3. So this goes ahead and just returns false. So there's nothing much for us to do here. We do not have enough values for this to be a mountain array. We'll just go ahead and return false. Let's take a look at the second example they give us. In example 2, the array R is going to be equal to 3, 5, 5. For this example, the length is greater than or equal to 3. So then we can actually go ahead and check each value. But if you look here, we increase from 3 to 5. However, we do not increase from 5 to 5. Since we don't increase from 5 to 5, this means that this is not a true mountain array because it does not strictly increase. So this would return false. Cool, now let's go ahead and take a look at the final example they give to us. In this example, they give us an array R, which is equal to 0, 3, 2, and 1. And in this case, the length of the array is in fact greater than 3. And if we go ahead and take a look at what this is going, we are increasing from 0 to 3. We are decreasing from 3 to 2. And we are decreasing from 2 to 1. Since we strictly increased and then strictly decreased, we didn't have any plateaus or we didn't have any switch of directions, we can go ahead and return true for this one. So hopefully this helps you think about what we're trying to accomplish here. Let's scroll back up and take a look at our constraints. The constraints they give us aren't really anything special. The first one, I is less than or equal to array.length is less than or equal to 10 to the 4. This is basically saying that the length of the array can be between 1 and 1000. Something to note here, if you remember, one of the ways to have a valid mountain array is for the array to have more than 3 values. So that means since the smallest length is equal to 1, this is something that we're actually going to check for whenever we're doing our solution. Next one says 0 is less than or equal to array I is less than or equal to 10 to the 4. This one is literally just saying the values inside of the array can be between 0 and 1000. So we don't really have anything too crazy to worry about here. So once again, our goal is to go ahead and check each value as well as their surrounding values to determine whether or not the array is strictly increasing or decreasing to make a mountain array. So now the most important factor of solving this problem is the definition of a mountain array itself and then deciphering that definition. Once again, to be a valid mountain array, it must increase in values for at least one index, have a peak, and then decrease for at least one index after that peak, which is why I, we must have at least 3 indices inside of the array. Another small gotcha to this problem is that once it has started decreasing from the peak, it must always decrease all the way down to the end of the array. We cannot have some point where there's 2 indexes with the same value, basically kind of evening out or plateauing, and after it decreases, it cannot start increasing again. So those are all of our rules. So this problem can sort of be described as a state machine, where the problem is going to have 2 states, increasing and decreasing, and to be able to pass the test, it must pass through both of these states only once, and it can't be interrupted while going through either of those states either. Let's go ahead and take a look at some of the pseudocode for this problem, and then take a look at how our example might break down with that pseudocode. Since the smallest value of the array could possibly be less than 3, the first thing we need to do is go ahead and check if the array.length is greater than 3. If it's not, we need to go ahead and return false. This will be the first part of our checks. Then we also need to make sure that we start out by increasing and not decreasing. So we need to go ahead and check the first 2 indexes for increasing values. If it does not increase from index 0 to index 1, we want to go ahead and return false. If we pass our first 2 checks, then we want to go ahead and set our state to increasing. Then we can go ahead and loop through each of our elements inside of array. So now we're going to check the state as well as some of the values. So the first thing we want to do inside of our for, so the first thing we want to do for each element is see if the state is increasing. If the state is increasing and the value at the next index is greater than the value of the current index, we just want to continue the loop. If the state is increasing and the value at the next index is less than the current index, we need to go ahead and switch the state to decreasing. Then if our state is in decreasing and the value at next is less than index at current, we want to just continue the loop. If the state is decreasing and the value at next is greater than the value at current, we want to return false because this is not a proper mountain array. If we've made it through the loop and the state is not decreasing, then that means we never started decreasing, so we need to return false. Otherwise, we want to return true. I know I ran out of space a little bit here, but basically we're going to go through, check the state, check the values at next, make sure things are lining up, and then if something is not right, we'll go ahead and return false. Otherwise, if we make it all the way through the loop and we increased and decreased, we'll go ahead and return true. Let's go ahead and take a look at our example and run through our pseudocode to make sure everything looks good. So for our example, we're going to start out with array equal to 0, 3, 2, and 1. So our first check is if array.length is greater than or equal to 3. It is, so we'll go ahead and continue. Then our next check is to see if the first value and the second value are increasing. In our case, index array 0 is equal to 0 and index array 1 is equal to 3. So this means that they are increasing and we can continue. So we can go ahead and start our loop. For iteration I equals 0, our state is going to be equal to increasing, and our array I is going to be equal to 0, and our array I plus 1 is going to be equal to 3. So here our state is increasing and array I is greater than array 3 and array I is greater than array plus 1. So by our pseudocode logic, we just continue our loop. For iteration I equals 1, our state is still increasing. Our array of I is going to be equal to 3 and our array of I plus 1 is going to equal 2. So now we are increasing, and since we're in state increasing, our array I is actually smaller than array of I plus 1. So now we're going to go ahead and swap state to decreasing and continue our loop. For iteration I equal to 2, our state is now equal to decreasing. Our array I is equal to 2, and array I plus 1 is equal to 1. Since we are in state decreasing and array I is greater than array I plus 1, we want to continue. For iteration I equal to 3, the I plus 1 is going to be greater than array.length. So we want to go ahead and break the loop. We make sure that our state hit decreasing, and in our case it did. So this means we can go ahead and return true. So this one was a pretty quick and simple explanation. Let's go ahead and hop into LeetCode and actually get this down into code. Over on LeetCode, this is going to be a little bit more code than normal. The first thing we want to do is make sure that our array is greater than or equal to 3. So go ahead and first check if array.length is less than 3, return false. So that will take care of the parameter that the array mountain must have at least 3 indexes. Then we want to make sure that we're actually increasing. So if array 1 is not greater than array 0, that means that we're decreasing and should return false. So we're going to go ahead and say if array of 0 is greater than array of 1. If this is the case, we'll go ahead and return false. Then we can deal with our state. So let's go ahead and create a Boolean. I'm going to call this increasing. We're going to set this equal to true. So this is going to be the state. We're starting out increasing because we have already shown, or we've already proven that array 0 is less than array 1. Then we need to go ahead and loop through all the elements. So for int I is equal to 0, I is less than array.length minus 1 and I plus plus. And for each one of these, we're going to check our state and if we're still increasing or decreasing and whatnot. So first we're going to say if increasing and our array of I is less than array of I plus 1. This means that we are still increasing. So just go ahead and continue our loop. Then we'll check if array of I is equal to array of I plus 1. And this means that we've kind of plateaued and this is not good. We'll go ahead and straight return false because we have to either strictly increase or strictly decrease, or strictly decrease. We cannot plateau. Then we'll go ahead and check if increasing and array of I is greater than array of I plus 1. This means that we have hit the point of going ahead and decreasing. So we're going to say increasing equal to false and continue our loop. Then we'll go ahead and say if we're not increasing. So now we're going to check if we're decreasing and our array of I is greater than array of I plus 1. This means that we are still going down. We want to continue. We are still decreasing as we expect. And then we'll finally check if we're not increasing and array of I is less than array of I plus 1. If this is the case, then that means we've started to increase again, and that's not good because we've already increased. So we need to return false. Now we need to make sure that we actually went through and increased. So if we are still increasing, we need to return false. Otherwise, return true. Now let's hope we didn't typo anything, and let's go ahead and try to submit. There we go. We get beats 100%, 1 millisecond. There are no 0 millisecond runtimes for this one. We also beat 59% of our memory complexity, so that is not too shabby either. If we wanted to, we could make this a little bit better, but I'm not too concerned about it. I wanted the best runtime possible here in LeetCode. As always, if you found value in the video, please make sure to like, comment, and subscribe. It helps out a ton. And as always, my name is Ethan, an encoder. I make videos like this every single week. So if you do enjoy them, please make sure to like, comment, and subscribe as I mentioned before. As always, have a great day, and I'll see you guys in the next video.